Hello students. Okay, this will be the last video in this series, which is just a review of area. So what we're going to look at here are some slightly more complicated shapes. So looking at this one here, often what you have to do when you get into more complicated shapes is you actually have to, or it helps anyhow, to actually draw some extra lines in. Hopefully a bit neater than mine, just to basically make it fairly easy to see what shapes you're working with. So once I've done that line there, hopefully it's now fairly easy to see that this consists of a rectangle, a triangle, and half of a circle. And to get the total area, I just need to get the area of each of those separately and add them together. So let's go ahead and do that. Then I want you to have a go at the second one, please. Okay, so to start with, area 1 is a rectangle. Area of a rectangle is length times width. Now we got to do a little bit of a calculation here. Let's see how we're going to do this. Okay, that distance, oh no, it's okay. That distance is 70. So I was going to try to use that 100 and subtract, but that distance is 70. That distance is 60. So it's just going to be length is 70, width is 60. 7 times 6 is 42, and add on a couple of zeros, centimeters squared. Sometimes when you have these more complicated shapes, you actually have to do some subtracting, which is what I was about to do there until I realized it wasn't necessary. Okay, let's have a look at area 2. Okay, this is going to be a triangle, which is base times height divide 2. The base of the triangle, well, here's what we have to subtract. The whole length there, the whole length there is 100. That's 70. So we've got to work out that that distance there is 70 minus 100, 100 minus 70, which is 30 centimeters squared. So the base of the triangle is 30. The height of the triangle is, let's have a look at that. There it is right there, 60. So base times height all divided by 2. Now I'm going to do this one in my head, and the easiest way to do these in your head is to say, well, I can divide either of those numbers by 2. I'm going to do that one because it's easier. 60 divided 2 is 30. 30 times 30 is 3 times 3 is 9, plus 2 zeros. So that's 900 square centimeters. And the third shape that I'm going to do is half of a circle. So let's go ahead and do area 3. Okay, now a whole circle is pi r squared. A half circle, I could either put it over 2 or I can just go divide 2. So I've got to just use a bit of common sense there. Now, what is the radius of the circle? Once again, you got to be a little bit careful. That distance is 60, therefore that distance is 60, but that's not the radius. That, of course, is the diameter. So the radius is going to be half of that. The radius is going to be 30. So you got to be a little bit careful with radius and diameter. You don't always just use the number given in the diagram. You've got to use a little bit of common sense as well. Okay, let's go ahead and use our calculator for that. And clear everything off. So we start fresh. I need a pi button, shift pi, multiplied by 30 squared, multiplied, whoops, that's a mistake, so I can hit my delete key, divided by 2. Quick check. Pi times 30 squared divide 2. Yep, looks good. Equals. And we're rounding this to, I forgot to look, we're rounding this to the nearest whole number in this case. So it's just going to be, I'll keep a couple of decimal places just to be sure. 1413.72. That one rounds up to a 2. So 1413.72. 1413.72. And then finally, I might even put a line there to get the area of the whole shape, it's just going to be area 1 plus area 2 plus area 3. Give myself a bit more room to work. Area 1 is up here, 4,200, plus area 2 is 900, plus area 3, I'll put it down here so don't encroach on the space for the next question, 1413.72. Let's go ahead and add those. Well, I've already got the 1413. Here's another nice little trick is rather than retype that into there, I might as well use the whole thing. Okay, that means I've got all the decimal places there. It saves me typing. There's a good chance if I try to type that in, I'll make a mistake. So it's easier, if possible, leave the value you already have there and just add to that. So I can go plus 4,200 plus 900. Okay, so the answer I had before, that looks all pretty good. And I need to round it to the nearest whole number. So I'm going to round it to 651. And looking at that 3, looking at the next decimal place, it's 5 or bigger, so that 3 becomes a 4, 6514. 6514 centimeters squared, and I should have put centimeters squared on that one. So once again, we had to find 3 areas, and then we had to add them together. Okie doke. Stop the video, have a go at this complicated shape over here, well, somewhat complicated shape, and then turn the video back on. We'll check your answer. Okay, welcome back, students. Let's see how you went. Okay, so again, this little line like that can confuse some students. It looks like there might be 2 shapes there. But in fact, of course, if you look at it, and it doesn't hurt to do this sort of stuff, that's really just a trapezium, or as they call it in America, a trapezoid. So that's going to be area 1, and that's going to be area 2. Okay, let's go ahead and start. Okay, now the area of a trapezoid, now the way I like to think of it is you basically find the average of those 2 sides. But the formula basically says the same thing. You add the 2 sides together, A plus B. So in fact, I might even go ahead and label those. That's A, that's B, that's H. A plus B times H all over 2 is the equation for the area of a trapezium. So let's go ahead and sub our numbers in. So brackets, well, A is 27. B is that length, which isn't given to us, but you have to realize or use the fact that this is part of a circle. So that's the radius, and that's the radius, therefore B is 15. So once again, we had to get the information for this shape from another part of the diagram, and that's quite common. And then multiplied by the height, and that's given to you as 12, all divided by 2. Okay, let's go ahead and type that in very carefully. Oops, I just hit the wrong button. Try that one. Drag that out of the way. All clear. Okay, again, it makes it easier if you have a calculator that actually has a fraction button on it. That way I can set it up so it looks exactly like what I've written down. So 27 plus 15 in brackets, multiplied by 12, down arrow, all divided by 2. I don't need to go to the right. I could do that, but I don't have to. And then equals, and that gives me 252 square centimeters. So 252 centimeters squared. Okay, off to area 2. Well, once again, this is a sector. So we write down the formula. theta on 360 times the area of a whole circle times pi r squared equals, okay, the angle that we need is 110 and the radius is 15. So 110 over 360 times pi times radius squared. Once again, we just type that into our calculator. So the fraction button, 110 over 360, right arrow, times pi button times 15 squared. Oops, once again, I've messed it up somehow. Don't know what I've done, but anyhow. Okay, 110 on 360 times pi times 15 squared. Okay, just checking it. All that looks pretty good. Press the equal sign. And let's keep a couple of decimal places. 215.98 is the area that I have so far for that part of the shape. That's centimeters squared. And to get the total area, it's area 1 plus area 2. Scrolling on down. Area 1 is 252 centimeters squared. Sorry, that's area 1. Area 2 is 215.98. In fact, I did something very naughty. Normally, you don't put your units in until the end. No need to put them in there. Just complicates things unnecessarily. Add those two numbers together. So calculator once again. 252 plus 215.98. Okay, looks good. Equals 467.98. Now I need to round that to the nearest whole square centimeter. So 267.9, that's going to round up, sorry, 467.9, that's going to round up to 468. 468 centimeters squared. And there are the two correct answers. So once again, to summarize, when you're finding the area of compound shapes, it's just a matter of finding the area of the simple shapes that make up the compound shape, and then just add or subtract as necessary. And sometimes you might have a missing length that you need, a missing dimension. You've got to find it somewhere else in the shape. Okie doke, we'll leave it at that. And what I'm going to do now, not straight away, but next is work out or show you how to find the volume of three-dimensional shapes.